Hello and welcome to all of you in my channel Blue Chip Finance. In this video we are going to discuss about the topic of exponential smoothing, which is a subtopic of forecasting techniques of operation and production management. And in this video we will discuss about MAD, MSE and MAPE. So first of all, what is exponential smoothing? Exponential smoothing, we can say that when we talk about moving average of time series analysis, which we performed in previous videos, there we assigned equal weights to the all previous values of the time series analysis. But in exponential smoothing, we assign unequal weights to the values, which means that as time passes, less weights are assigned to the older values. And smoothing constant, as you are seeing here in this example, alpha is a smoothing constant, and when we take this smoothing constant higher, it means that we are assigning more weight to the recent values of time series analysis, and which means that more value shows the drastic change in the forecasting value. So here in first example, as the question is mentioned here, that in January a car dealer predicted February demand for 142 Ford Mustangs, and actual February demand was 153 autos. So it was forecasted that demand will be 142. This forecast was predicted in January, but actual February demand was 153 autos. So using a smoothing constant chosen by management of alpha equals to 0.20, which is a measure of systematic change, the dealer wants to forecast March demand using the exponential smoothing model. So here forecasting formula is equals to f t minus 1, which means previous forecast, plus alpha, and which is a smoothing constant, multiply by previous time period actual minus previous time period forecast. So here demand for forecasted demand for February was 142, as we are seeing here that it was 142, plus smoothing constant is 0.20, and multiply 153 was the actual demand. So 153 minus forecasted demand was 142, and when you sum up this, it will be 144.2. So if the smoothing constant is changed to 0.30, what is the new forecast? So if we change this volatility factor from 0.20 to 0.30, so we will see that as we are seeing here, that new forecast for March will be 145.3, but with 0.20 for smoothing constant, it was 144.2. so as smoothing constant increase, the forecast for the new time period will also increase. So after understanding of the calculation of forecast under smoothing constant with different smoothing constant, Now we turn to first of all discuss three different formulas. One is mean absolute deviation, and abbreviation of this is called MAD, and it is equals to sum of actual minus forecast uh, divided by n. So these line shows that it is the absolute deviation, in which you just ignore the minus signs. After that, mean squared error MSE is equals to sum of forecast error square divided by n, and mean absolute percent error, or we can say MAPE, is sum of actual minus forecast error divided by actual and whole multiply by 100 and whole divided by n. And error, as we discussed earlier, that actual minus forecast, as we used here actual minus forecast, is called error, and cumulative error is cumulation of this error. So now one by one we will see these calculations with the help of different questions which are taken from the book of J. Hazer. So during the past 8 quarters, the port of Baltimore has unloaded large quantities of grain from ships. The port's operations manager wants to test the use of exponential smoothing to see how well the technique works in predicting tonnage unloaded. He guesses that the forecast of grain unloaded in the first quarter was 175 tons. Two values of alpha are to be examined. Alpha equals to 0.10 and alpha equals to 0.50. So compare the actual data with the data we forecast using each of the two alpha values, and then find the absolute deviation and MEDs. So here data is given for different 8 quarters, from quarter 1 to quarter 8, and actual tonnage unloaded are also given. So these two columns are related to the questions. So now first of all we will forecast about smoothing constant 0.10, and here first forecast value for first quarter is 175 tons is given in the question. So for first quarter forecast is 175 on both smoothing constant 0.10 and 0.50. So from second quarter we will apply formula which we already discussed here, that previous forecast plus alpha minus error, actual minus forecast. So here as we are seeing that previous forecast is 175 and alpha is 0.10, and multiply by previous actual is 180 minus previous forecast is 175. So forecast for second quarter is 175.50, and for third quarter previous forecast is 175.50 plus alpha equals to 0.10 minus previous actual is 168 and minus previous forecast is 175.50. So forecast for third quarter is 174.75. Similarly for fourth quarter is previous forecast is 174.75 plus alpha 0.10 multiply by previous actual is 159 and previous forecast is 174.75. So in this way you can calculate the forecast with alpha 0.10, and all the calculations are given here. For alpha 0.50 the same process will be followed, but use alpha 0.50 instead of 0.10, and calculated values are given here 175, 177.50 and so on. So after taking these values, for example these values are given for cost with alpha or smoothing constant 0.10, and these values are given while taking smoothing constant 0.50 for cost. Now we need to calculate absolute deviation. Absolute deviation is equals to actual minus for cost while ignoring signs of minus. So here actual is 180 and for cost is 175, so equals to 5. Similarly 168 minus 175.50 is 7.50, ignoring sign of minus. 159 minus 174.75 15.75 and so on. And similarly for absolute deviation for smoothing constant 0.50, actual is 180 and for cost is 175 equals to 5. Actual is 168 and for cost is 177.50 equals to 9.50 while ignoring minus signs. And 159 minus 172.75 equals to 13.75 and so on. So in this way we can calculate absolute deviation for smoothing constant or alpha equals to 0.10 and absolute deviation for smoothing constant or alpha equals to 0.50. So here sum of actual minus for cost is equals to 82.45 and here sum of actual minus for cost for alpha equals to 0.50 is 98.62 and n, which means time period, there are 8 quarters, so n should be 8 and mean absolute deviation is 10.31 if we take smoothing constant 0.10 and mean absolute deviation is 12.33 when we take smoothing constant equals to 0.50. So as you are seeing here, mean absolute deviation, as you know, if you know about statistics, that it is a measure of dispersion. So if dispersion is greater, then the risk factor is also greater, and we can say that on the basis of above result, smoothing constant 0.10 is preferred over alpha 0.50 because its MAD is smaller. So as you are seeing here that at smoothing constant 0.10 your MAD is 10.31 and for 0.50 your MAD is 12.33. So if the smoothing constant is changed from 0.10 to 0.20, what is the new MAD? Try yourself. Next, in example number 3, the operations manager for the Port of Baltimore now wants to compute MSE for alpha or smoothing constant 0.10. Use the same data as given in the previous question, or we can say in example number 1. So data is same, there are 8 quarters and actual tonnage unloaded is given in the second column. And now we will calculate mean squared error MSE, which is equals to for cost error square, sum of for cost error square divided by n. So what is for cost error? We already calculated here. Actual minus for cost while ignoring minus signs is your for cost error. So for cost error for 0.10 smoothing constant is 5, 7.50, 15.75 and so on. And we just take same here, take the square, 5 square 25 minus 7.50 square 56.25, 15.75 square 248.06 and so on. And sum of this for cost error is 1526.46. And 1526.46 divided by 8 is equals to 190.8. Is it good or bad to choose alpha equals to 0.10? We have no answer unless we check other alphas or smoothing constant, and then we can compare either it is good or bad. In above both methods there is one drawback, that if the values are large enough, then the answer will be large also. So there may be some computational problems. To avoid this issue, we can use MAPE. And now we will go to the third technique, and that is MAPE, mean absolute percent error. So mean absolute percent error, the rest of the data is same for cost error with alpha 0.10, as we already calculated here, as you are seeing here that it is for cost 175, 175.50, 174.75, and the formula we already discussed. Now what is needed here to understand, and that is absolute percent error. Absolute percent error is actual minus for cost error while ignoring minus sign divided by actual multiplied by 100. So here what is your actual minus for cost? Actual is 180 and for cost is 175. So 180 minus 175 while ignoring minus signs, if it is and that is equals to 5 divided by actual. What is actual? Actual for first quarter is 180, and 185 divided by 180 multiplied by 100, and that is equals to 2.78%. Now for second quarter, actual minus for cost is 168 minus 175.50 while ignoring minus signs, and that is 7.50 divided by actual is 168, and result should be multiplied with 100, so that is 4.46. For third period, 159 minus 174.75 equals to 15.75 divided by actual, that is 159, multiplied by 100, and result is 9.90, and so on. And at the end, just take the sum of all these percentages, and that is 44.75. That is equals to sum of actual minus for cost absolute error divided by actual multiplied by 100 and divided by n. So this whole part is calculated here, 44.75 divided by 8, and result is 5.59%. So MAPE express the error in percentage. It is used in extreme values. We can make a conclusion about alpha or something constant when we assess several alphas, because we need the comparative analysis between or among different alphas. So what is MAPE? When alpha equals to 0.50, compare the error, try yourself, and make your practice. So these were three different techniques: MAD, MSE, and MAPE. And in the next coming video, we will discuss about some more different topics of exponential smoothing, including tracking signals. So just practice these questions which were instructed in the video. So thank you.